Joe Rogan asked, "How is Walter Russell's periodic table perceived by people who study this?" He means like people who study chemistry and physics. And Terrence Howard replies, "Well, now everybody wants to use it. In my book, there's a picture of Einstein reading Walter Russell's second book, The Universal One. I haven't seen a single serious chemist, physicist, or astrophysicist interested in using Walter Russell's periodic table. It includes less information rather than more, and everything it has is either misrepresented or already known. Only people who know next to nothing about chemistry seem intrigued by it. As for Einstein reading the Universal One, Einstein lived from 1879 to 1955. The Universal One was published in 1974. So we don't even have to go looking for that picture. Einstein wasn't alive when that book was published." And Walter Russell says, and one of the quotes Einstein says on his deathbed, "I should have spent more time reading Walter Russell's work." I literally have no idea where Terrence Howard pulled this quote from. It literally cannot be found. He probably made it up, or maybe somebody else made it up and told him. Terrence Howard then says, "You look at the air, it looks clear." He's referencing the idea of ether here. "But if you change the pressure condition, the balance of the change of pressure condition, well, we call that condensation." This is not correct. Pressure can cause condensation, as can many things, such as microbes collecting molecules of what is condensing, or colder temperatures. But it is not the air that condenses, it is the molecules in the air, like water molecules. The air does not become water. Water that is in the air is brought closer together. So he's claiming that, like, oxygen in the air becomes H2O, and that is oxygen becoming hydrogen by higher pressure, becoming condensation and turning into water that rains from the sky, for example, from clouds. It's really not how it works. Instead, you have H2O already in the air, but let's just use this as H2O right here. So you've got one H2O over here, you've got one H2O over here, and as they get closer together through changing pressure conditions, now I'm using pressure conditions, changing pressure or changing temperature, or maybe there's a little microbe chilling here and he bumps into this water, and then he bumps into this water, and he starts collecting a bunch of water around himself. That is how you get clouds. Or, little grains of dust in the clouds collecting water around themselves. So he says, it creates clouds, and you change the motion conditions, whether it's moving quickly or slowly, it's going to become snow, rain, hail. So everything comes down to one of two forces. Either you're breathing in and filling up something, or you're pouring it out. But the scientists, they ignored Walter Russell's work because he didn't include any equations inside of it. I'd just like to bring up Richard Feynman and Feynman diagrams real quick. It's, right here. This is a Feynman diagram with Richard Feynman next to it. And there are no equations in this diagram, and it has been said to have revolutionized nearly every aspect of theoretical physics. So they ignored Walter Russell because he didn't include any equations, but Richard Feynman is one of the most famous scientists of all time, and there's no equations in his Feynman diagrams. The difference is that the Feynman diagrams actually make it way easier to manage incredibly complex math equations by just using these diagrams, which have very specific the way to set up. Like, this is like a photon, these are electrons exchanging a photon. You could look up Feynman diagrams, watch videos on it. It's awesome. Richard Feynman is amazing. One of the greatest scientists of all time. Terrence Howard then says, he talked philosophically regarding how things behave in comparison to laying down and following some Newtonian or calculus writing. He said he based things on, let's explore them naturally, and that's why I did it with my book. Or that's why I did with my book. Or maybe he said what? I might have mistranscribed that. What Walter Russell was missing is he didn't have wave conjugations. He didn't have Mira shapes, the all shapes. And that was because of a mistake that was made 6,000 years ago, maybe. They took the flower of life. You'll see the mistake that they made because they believed in straight lines. The church was promoting the idea of straight lines. Let's see if I have that pulled up here. Here we go. This is the thing that he was using. You can find the link to this in his book, and it's got his shapes here. So this is the tetratarian, the concave. Oh, can't look underneath it. The concave tetrahedron that is a wave conjugation, and you can see how this one lines up with this part of the pattern of the flower of life. So philosophy has a place in physics when it is properly attributed, like the notion of chirality, the expansion and contraction even, positive and negative charge. The connection between the flower of life and the Platonic solids is a loose fit at best, especially noticeable with the dodecahedron. Now, there was a video where he showed, essentially, if I zoom out of this, he showed like a tetrahedron being formed here. If you can see my cursor, I don't know if you can. Anyway, you can see that with 3 points on this. Oh, there we go. I can move the cursor with this. Okay. So like this point here, to this point here, to this point here, or if you take it wider, you can go here and then draw a line through these, and then draw a line through those, and then draw a line back across, and create basically a tetrahedral shape inside the flower of life. But when you start trying to draw like the dodecahedron and the icosahedron, it doesn't quite fit. It's a little bit forced. Terrence Howard says, all of our axioms, our postulates, have been built off of those things, meaning the Platonic solids. So I'm assuming these things are straight lines and Platonic solids, which is an extreme sweeping generalization. I would like to see Terrence Howard break down how any axioms and postulates exist specifically because of the ideas of straight lines and Platonic solids. He then says, but you'll see that instead of following the natural curvature of these 64 circles overlapping, they averaged the space where they met, and they invented straight lines. Straight lines were observed in nature and not invented. The ability to see down to the atomic level was not available for a majority of human history. Like mathematics itself, straight lines exist primarily as abstract concepts. One does not exist in nature, but one thing can be accounted for. Straight lines may not truly exist in nature, but a straight line between two objects can be imagined, and objects do in fact move along perfectly straight line trajectories unless acted upon by a force. Terrence Howard then says, because they believed that the world was flat. They believed the world was flat at the time, and the church promoted it. The Pythagorean theorem comes off of this cube, a squared plus b squared equals c squared. And that's not a cube. So Empedocles and Anaxagoras gave arguments in 500 BC as to the spherical nature of the Earth. The Pythagorean theorem relates to triangles, not a cube, and it was used as early as 1900 BC, seen in Babylonian tablets, long before Pythagoras rediscovered it and named it the Pythagorean theorem. But Pythagoras called it the Pythagorean theorem after they had already begun figuring out that the Earth was round. And by figuring out, I mean like actually trying to measure the roundness, not just the idea that it was round. Terrence Howard then says, it is the oldest symbol known to mankind, referring to the flower of life pattern. Now, I'm not trying to denigrate the flower of life here. The flower of life is a really cool pattern. However, it is not, in fact, the earliest symbol. This one right here, an etched bone fragment from the Middle Paleolithic period found in central Israel. A bone fragment marked with symbols was found in early 2021 in the Rami region of Israel. At approximately 120,000 years old, it is possibly the earliest evidence of human use of symbols ever found. As such, it is an important clue to how symbolic expression developed. That's pretty cool. Flower of Life is an old symbol, though. You see it all over the place. It's a really cool symbol. So, Terrence Howard says, why don't you just take the pieces that make up the flower and put them together based on universal ratios? So then this is now where he gets into this thing. I jumped the gun on this, got into it a little bit early. So he says, this shape right here, this is the negative space where four bubbles meet. They can't touch each other. We're talking about, how the flower of life is arranged here. This is hydrogen, and as I was saying, electricity is always trying to get to the center of that triangle, but it gets pushed out. And now you see it has four contractive poles, which is the electric poles. So he's saying these spots right here, the surfaces, these are the electric poles of this object, is what he's saying. He then says, because electricity is seeking higher pressure condition and forcing it in, where magnetism is seeking a lower condition and spun out. So the vortices, those tips, that's the magnetic field. That's where they begin, but it has an equal attractor and an equal amount of repulsion. They gave me the patent to that. I call it the tetratarion. So where four bubbles meet, where they can't touch each other here, is in reference to the way that they're arranged on the flower of life pattern. So this would be one bubble, or this bubble, for example. If the pattern was layers of three-dimensional spheres or bubbles, and you would say rather than where they can't touch, what he means is where they don't touch based on the flower of life pattern, and he's saying universal ratios to mean this pattern specifically. Terrence Howard is claiming that this is hydrogen based on the idea of the +4 and -4 oxidation states that are related to the four faces and four corners of the tetrahedral shape. So he's saying that these points are the pluses and the faces are the minuses, and that's why it is hydrogen. So the concavity indicates an inward flow, and the points indicate an outward flow. Unfortunately, hydrogen only has +1, 0, and -1 oxidation states, which means reality isn't playing along with Walter Russell's ideals. So therefore they must be there, but we just can't perceive them or identify them with experiment. Right? So if they don't show up in Walter Russell's chart, or rather if they're on Walter Russell's chart but don't show up in nature, then that just means they are there but we can't see them. We can't detect them in any way. And then electricity seeking higher pressure condition translated means that electricity is flowing in toward the center because it is attracted to a higher density of ether. There's no explanation as to why that's the claim. And therefore, because we defined magnetism as being opposite, it's doing the opposite. We're ignoring the part where magnetism is supposed to come out of the equators for this, and ignoring that this shape is the void space between bubbles. It is now a fundamental shape, creating the spheres rather than the other way around. The corners are being defined as vortices arbitrarily, since they in no way resemble vortices. There's no spinning to these things. They're just points. There's no vortex there. This is being said simply to line up with the previous ideas about how magnetism operates. Terrence Howard claims that this shape is patented, but I've found no evidence of a patent. It's a concave tetrahedron, which he is calling a tetratarion. This is one of the shapes he is referring to when he says wave conjugation. To Terrence Howard, this shape is a wave conjugation, where curves meet. Terrence Howard next says, when 8 bubbles meet, this is the negative space where 8 bubbles meet. If you, let's pull that up. That next shape. So when 8 bubbles meet, this is the negative space where 8 bubbles meet. If you look, I haven't violated anything. It fits perfectly inside there. But you'll notice it has 8 contractive poles, but only has 6 magnetic poles, 6 vortices. So it has a greater electric potential than repulsion. So maybe this is the strong nuclear force, and the previous one was the weak nuclear force, the tetratarion. So I was like, okay, I called this the Huntian after my son. So I was like, what happens when 6 bubbles meet? We'll get to that in a second. Alright, so there's a little dot there. Right here, this you can see this. This is where he made this object connected to that little dot, and he forgot to hide that. That's fine though, it's cool. So what we see here is that it does touch on 3 points, like the tetratarion shape, but if you look at it from the top, you'll notice it doesn't quite line up the same way. And if you imagine that there is a bubble right here, it doesn't really line up with the flower of life pattern anymore. That one kind of does. This one kind of lines up with the idea of a bubble, but then this one doesn't, and that one doesn't. These ones do down here. So these 3 down here do line up. This one at the very bottom does not. The one at the very top doesn't, and these 3 up top would not line up in any way that the flower of life pattern would be arranged in 3 dimensions. So we've completely abandoned the flower of life pattern at this point. Because even though there's these 3 points at the bottom that still line up, a 3-dimensional arrangement of bubbles in the flower of life pattern will never make an octahedral shape like this between them. You can arrange bubbles to create this shape, but not while adhering to the flower of life pattern, which was so important before. You'll note his immediate defense If you look, I haven't violated anything. So you know it has been pointed out to him before. Wild speculation about the strong and weak nuclear forces have literally no evidence or any real argument. Just saying that this has 8 more inward poles. Is that the reflection of the sun? Interesting. Anyway, the eight concave faces and the 6 points at the corners is being equated to the strong nuclear force, but there's no actual explanation as to why. It's just some random thing, some random claim that can't be verified at all and that has no justification. Terrence Howard then says, now you see that it has these huge bubbles. Okay, we're at where 6 bubbles meet now. Now you see that it has these huge bubbles, fast moving, but there's 6 strong spheres that's going around this. But the greater attractor has grabbed the 2 weaker attractors, and this looks like just like a photon. And guess what? It has 30 poles. What is the speed of light? 299,752,400 something. They round it off as 300 million kilometers squared, or kilometers per second squared. Okay, so where 6 bubbles meet is actually quite readily apparent on the flower of life pattern. It's a single point with no dimensions. All right, you've got 1, 2, 3, 4, 5, 6. Single point. So we've completely abandoned the idea that this is fitting the flower of life now. These wave conjugations appear to be where Terrence has jumped off of the Walter Russell boat and is now showing his own work, his own ideas. A cursory glance will see that this new shape is assembled completely arbitrarily and no longer has anything to do with the original principles that Terrence Howard started with. Which is why he says huge bubbles. Though if you look, you will see that the curved surfaces do not support the idea of huge bubbles, just multiple bubbles. They curve up too much in the middle there. A singular bubble can't do that. There's no one sphere that's going to make this whole thing. This is 2 distinct bubbles. So strong spheres again. He says strong spheres. So again, if we look closely, that's not the result of a single sphere making the same indentation between the concave octahedral face and one of the concave tetrahedral faces. Terrence Howard knows this, so he's blustering. He's lying to you. And probably to himself until he believes it, if he can manage that. But based on his blustering, you know he doesn't really believe it himself. So he's trying to ignore it. This, as you will see, is how Terrence Howard operates in all facets of his life. Fast moving is another attempt to bluster away the fact that these shapes are no longer conforming to the original principles Terrence Howard started with. The idea that the inward flowing poles, the concave faces of these shapes, are pulling each other together to form this shape is contradicted by the earlier description Terrence Howard gave us using rivers or hoses. The flows are moving away from each other, which means they are not attracting. They are pulling away, not together. So these positive poles would repel each other, right? If this is the magnetic outward flow and this is the electric inward flow, the way that they're lined up, they would naturally be repelling each other based on Terrence Howard's own claim of how these things are supposed to be working. So that's why this assembly is completely arbitrary. Also, he claimed that it looks like a photon. I happen to have pulled up already. What does a photon look like? There's a whole lot of ideas of what a photon looks like, and none of them look like this Huntian shape, unfortunately. Let's get back to that. So he also said 30 poles is basically exactly 300 million, which is 299,752,400-ish, and it looks just like a photon, so it must be light itself. Also, it's meters per second, not kilometers per second. But we won't ding him for that. At least he memorized the digits. He doesn't mention it, but he calls this wave conjugation the Mira wave field. We can find that in his book over here. Somewhere. We're getting to it. Here we go. Okay, so we got the Tetratarian, the Huntian, and now the Mira. Now you'll notice here he changed it up a little bit to make it look a little bit more like it's supposed to be 6 separate bubbles. But if you look at it here, as we were just now, this and this are not the same thing. So he's fudging the corners a little bit. So let's see here. And Mira is his wife. So in this book, or in his book, he claims that most of the mathematic and scientific world will both ignore his work and also steal and rebrand it. But it won't be possible because for some reason these shapes will only work if you think that 1 times 1 equals 2. And what exactly are these bubbles supposed to be that are making these shapes, and why are they supposedly doing what they're doing? And how is it that the shape of the bubbles is creating these wave conjugations, but really it's Walter Russell's version of the electricity and magnetism? Why does it feel like these things are being attached arbitrarily? And what makes these basic shapes such a revolution? None of this is ever shown, just a lot of declarations and wild speculation with no real basis. It's fantasy, and it's not a well put together fantasy at that. Terrence Howard then says, but if you look at it from the top, you'll see that I haven't violated anything. This looks like what happens in nature. Let's go back to the thing. So we're looking at it from the top. He's saying he hasn't violated anything. I don't know about that. So he also says this is what happens in nature. Where? Let's see it. He also says, so they gave me the patents to this, the collection of shapes. But you'll see that there's 6 unaccounted for electrical poles to it. So he's talking about like this one, and this one, and this one, and this one, and the one down there below. 1, 2, 3, 4, 5, and 6. Now he's not going to count these ones as unaccounted for electric poles. He's just going to count the ones around the Huntian shape as the unaccounted for poles. So he says, what happens when 12 bubbles meet? And again, he said he has the patents to these, but the USPTO does not have these listed. I could not find any reference anywhere to a patent on these shapes. So he's claiming he has patents to these. They can't be found. So if he really does, then it's not with the USPTO, and he should show them He should show the patents so that he's not just claiming that he has patents that he doesn't have. Terrence Howard then says, another stable structure that we basically see in nature, this is the where 12 bubbles meet now. But there's 4 unaccounted for electric poles to it. He also says, you'll see 1 on the bottom and 3 on the sides. This is the basis of crystallization, laws of crystallization that forms. And you can go to the last one. I was like, what happens when 24 bubbles meet? We'll go to that one in a second. So this one, if we go to his book, that's not his book. If we go to his book, you'll see he calls this one the Aubrian wave fields, or the Aubrian wave conjugation. And that's named after his daughter. He claims that this is the pressure and motion condition of 12 bubbles meeting, but we can clearly see that you need 20 bubbles according to his own established principles. So 1 bubble here, 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 and here. That's 4 bubbles per face. So 4 here, 4 here, 4 down here, 4 down there. And then you also, let's see, so that's 16, 17, 18. I already counted those ones actually. So let's go back to the 16. This one doesn't have one, so. Oh, actually, you need the ones under here too, though. So let's just count by these. So you've got 1, 2, 3, 4, and each of those needs 4. So that's 16, and then this one needs 8. So you've got, right? This one needs 4, that one needs 4, that one needs 4, that one needs 4, that's 16. And this one needs 8, because there's no bubble that's going to make both that and that. So if we're still counting this thing in the middle here as being part of this, then you actually need 16 plus 8, which is 24 bubbles, according to his principles. And again, this no longer has anything to do with the flower of life pattern, except that it is sitting on top of it. Like these ones line up, but this one up here, this one doesn't line up with the flower of life, and this thing doesn't line up with the flower of life at all. If you removed the Huntian concave octahedron from the middle, it would almost fit, except for the extra tetrahedron on top would be out of place. Now, if you look up crystallography, you will see the actual basis for crystal structures, which has to do with the ways that elements bond with each other. This is not it. Also, let's remember that Terrence Howard said that a tetrahedron is hydrogen, and also probably the weak nuclear force. The Huntian is probably the strong nuclear force, and 2 hydrogens and 1 probably strong nuclear force equals a photon, and 3 hydrogens plus 1 probably strong nuclear force equals the basis of crystallization, according to his claims. So let's continue on. He says, this is the negative space where 24 bubbles meet. This isn't that in any way. This is 8 tetrahedrons and 1 Huntian. It's only 24 if you ignore the Huntian in the middle, which, because 8 times 4 is 24, right? So you're ignoring the 8 bubbles in the middle, which would make it 32. And if you do ignore the Huntian in the middle, why is it there? And why are the bubbles meeting in this specific way? It's arbitrary. I mean, yeah, you can connect the corners to each other, but he's talking about these corners being magnetic forces all flowing out. These corners they would be pushing against each other, according to his own claims. And the sides, the concave sides, would be pushing away from each other as well. He also claims that you cannot distinguish this from the background because all of the electrical potential has been accounted for. He says this would be the Bose-Einstein condensate, where something becomes indistinguishable from the fabric of space itself, the final state of matter. So Terrence Howard is saying that it can't be distinguished from the background now because all of the faces of the Huntian in the middle that isn't being accounted for in the bubble count have a tetratarion attached to them. Analyzing it by the electric and magnetic poles as defined by Terrence Howard, we can count 8 external magnetic vortices or poles and 24 external electric poles, the curved faces of the polyhedra. If we count all of the corners and faces, we have 32 magnetic poles and 32 electric poles, if we ignore the Huntian in the middle. If we don't, because it's there in the diagram, we have 38 magnetic poles and 40 electric poles. Ignoring the Huntian, the same logic that suggests that it can't be distinguished from the background because it's 32 and 32 would also make the tetratarion, which he calls hydrogen, also indistinguishable from the background, because he's saying that it's balanced out on the electric and magnetic, and that's why it's indistinguishable. So therefore, hydrogen should not be distinguishable either. And also the hydrogen, which is the weak nuclear force. So the weak nuclear force should also be indistinguishable from the... we're just following the same logic that he used to say why this thing is a Bose-Einstein condensate. Also, if we go to his book, you'll see that he calls this one the heavenly wave field. I could have sworn he also said something was called an Antonion. I'm not sure who Anthony might be in his life, but I could have sworn he said that there was one that was that. I don't know which one that was. So let's see here. Where am I? So he says, oh right, he claimed that this was the Bose-Einstein condensate. So Bose-Einstein condensation is seen in things like superconductors and superfluids, and is caused by extremely low temperatures, where fermions create Cooper pairs to behave in boson-like manners. A fermion is the state of matter where it takes up a unique position and pushes against other fermions. In the boson state of matter, which is essentially the energy state of matter, the bosons can occupy the same space. There's nothing about this collection of shapes that has anything to do with that. Terrence Howard then says, and the proof of this, the Platonic solids, they have a thing called discrete symmetry. You can put the cubes together. Maybe you can put the dodecahedrons together, but you can't put all of them together. So he's saying because you can put these octahedrons and tetrahedrons together, but with the Platonic solids, you can't put all the Platonic solids together, that his is better. So if we just ignored all the Platonic solids except for the octahedrons and the tetrahedrons, they'd be equivalent, I guess. Also, he's saying you can't put all the Platonic solids together. Obviously, he has never played Dungeons and Dragons. Let's see here. Where's that one? There you go. There's all the Platonic solids together, plus some D10s, which are not Platonic solids. So he says, but you can take the wave conjugations right here, and they form supersymmetrical systems where everything aligns. Supersymmetry is a theoretical framework in physics that suggests that the existence of a symmetry between particles with integer spin, bosons, and particles with half-integer spin, fermions. It proposes that for every known particle, there exists a partner particle with different spin properties. What Terrence Howard means by supersymmetrical is that it has more than one line of symmetry. Imagine if his wave conjugations were just perfect spheres. A perfect sphere has literally infinite lines of symmetry. I could be wrong, though. He could be trying to say that his heavenly wave field, wave conjugation, is a supersymmetrical system because he arbitrarily declared it as a Bose-Einstein condensate, which connects to the idea of fermions and bosons. Therefore, all of his wave conjugations are supersymmetrical, even though none of them have anything to do with integer and half-integer spin. And here is a very tiny GIF showing what integer and half-integer spin actually looks like. Well, I don't know about actually, but this is the idea where you have to rotate the object 2 times completely before it will return to its original state. So 1 rotation is half-integer spin, and then 2 rotations is a full integer of spin. It's pretty cool. So Terrence Howard then says, this is one of 4 supersymmetrical systems that I patented, and the reason I patented it was because when Walter Russell put his stuff up there, and then he got distracted. He'll get back to that later. And let's see, he pulled up something that said tetratarian wave conjugations, the contractive, electric, gravitative, quintessential ether. And then he keeps talking. He says, now there are all of these systems put together. This is where 12 bubbles meet. Let's go back to this thing here. So this is where 12 bubbles meet. They all something. Then I put 5 of them together, and they make these natural starfish. But when I put 10 of them together, they lay themselves out, and they predict all distribution of matter within the electric field. And you can see where 6 bubbles meet as you get to a higher point on it, where 6 bubbles meeting, still fitting perfectly where 12 bubbles meeting, and the where 4, where the 8, that's a supersymmetrical system. I put 12. If I put 20 of those where 6 bubbles meet, they make a natural dodecahedron that's naturally occurred. If I take where the 12 bubbles meet, that's where I made the linchpin from. Ultimately, from some of those pieces you've got right there, that all shape of it. If we look back over here, the all shape was way up here actually. It basically looked similar, but had like some extra curvature to it surrounding the outside of it. So I guess it was like a circle, perhaps, that was going around the outside of the tetratarian, maybe. And what he's talking about there, he's got a bunch of these shapes all put together. I don't know if he'll have it in his book. Oh yeah, here we go. Here's some of it. So he starts putting them together like this. This is his starfish over here. And I think this one might be his all shape. No, that's the heavenly wave field with a bunch of extra stuff put on it. But anyway, he starts arranging them, and That's why he's making those claims. Of course, he doesn't show how this predicts anything. He's just making baseless claims while playing with polyhedrons. And then now we get to the linchpin, which is Terrence Howard's word for 6 pentagonal shapes using straight lines that are connected together. I don't know. Oh, here we go. The linchpin. So you can see how there's a pentagon here, pentagon here, pentagon here, and then there's 3 more of them. So you get a total of 6 pentagons making this shape. And that's what he's calling a linchpin. Terrence Howard says, when Walter Russell published his book, he watched as people came up and collected Nobel Prizes for deuterium, for tritium, all these things he had discovered. And I was like, okay, let me wait until the patents are granted before I'll talk about it, so they won't be able to stop it. They might be the church, might be scientists, whoever the bad guy is in his story. So I'd just like to say that speculations are not discoveries. Also, I'm seriously not seeing these patents. There's only 3. Looking at the way that Terrence Howard writes and the way that he speaks, and then looking at the AR/VR patent, the only similarity I see is there's no actual technology involved. It's just arrangements of ideas with no technological invention. It's like drawing up a user interface on a piece of paper, but none of the coding, none of the mechanics. And we should, let's pull that up. Just go through it real quick. We're just gonna kind of scroll, just kind of get a brief view. A lot of words. He has some diagrams in here as well somewhere. Some claims. Oh. Does this one? This one doesn't show the diagrams. There is one somewhere you can find. Maybe if I jump back. Is this the one with the diagrams? No. Anyway, you can find the one with the diagrams. It's got some drawings of like a dude standing in a room and angles at which you would have like projections of augmented reality video onto a window, for example. So Terrence Howard then says, but what makes more sense? Where they invented straight lines in opening the flower, or will you actually take individual pieces of the flower and put it together based on universal ratios? Which one do you think is how the givers of that knowledge intended for us to use it? So Terrence Howard claimed that he got these ideas from an entity in a particular dream world that he visited many times, which I'm not going to say he didn't experience. I love dreams and weird stuff like that. But Terrence Howard's argument for the idea of straight lines coming from the flower of life just doesn't make sense. And even Terrence Howard didn't stick to the actual structure of the flower of life, which he is referring to when he says universal ratios. Except in the case of the very first shape, the tetrahedron, or the concave tetrahedron. Terrence Howard then says, but I started it off with 1 times 1 equals 2. Under what condition is it logical where the square root of a number added to itself will equal more than that number squared? But that's what happens with the square root of 2. That's what happens with most of the numbers. Let's go back to this. Okay. Now, I already covered this, but I'll do it again. Here's a very simple way to look at the issue with the square root of 2. So 1.41 or 1.4142135, etc. just happens to be the exact ratio where if you multiply any value by that ratio twice, you get double your starting number. This can be seen by the fact that the square root of 2 multiplied by itself is 2. So you can write it like this. The square root of 2 times the square root of 2 is 2. Or you can write it like this. The square root of 2 squared equals 2. And when you have the square root of something like this, essentially you're saying, if we had like a different form of notation, maybe the square root of 2 would be like that, and then 2 squared would look like that. And then this one would have a negative aspect to it, this one would have a positive aspect to it. Kind of, I mean, what you're looking at with square roots is that this value here, if it is squared, literally is this thing. And then if you take this value, oh jeez, you take this value and square it, it becomes this thing. So if we take 1 and we square it, we get a square with a side length of 1, with 1 box. And if we take 2 and we square it, there's a side length of 1 and 1, which is a total of 2, and a side length of 1 and 1, which is a total of 2. We're adding these, not multiplying them. And this is also side length of 1, which is a total of 2. And if we count these, it's 4. So 2 squared equals 4. But with a square root of 2, it's a little weird. So the square root of 2 can best be shown using a triangle. So where you would normally have 4, if we cut it in half, we are forming a triangle. Now this would actually, this was originally 4 and we cut it in half into 2, but let's pretend that this number is 2, right? Because we've got 2 total boxes. So if we take the square root of this, what we are doing is we are getting some amount of these boxes that when applied twice becomes this again. So we want to increase this by 41% essentially. So let's do a little ... here. Now the 50% line would be right here. So if we multiplied this, right, or this is the square root of 2, by 1.5, it would come out to this right here. And if we multiply it by 1.414235, it's going to be a little bit less, 41%, right? So it comes to here. And that's 41% more than this shape. But now we're going to take 41% more of this total shape, and that's going to equal exactly that much. So if this part equals the square root of 2. And then we multiply it by the square root, or actually, I fucked this up. Ignore all that, Jesus Christ. I was doing something else entirely. That was this right here becoming this with that right there. That's actually the square root cubed, right? Because we multiplied it once, and then we multiplied it again. So really what we're saying is if this number is 2, let's try this again. This is 2. So the square root of 2 is whatever portion of that shape, this shape, when multiplied by itself equals that shape again. And since one of these is 1.4, this is 1. This is our 0.5 line. So this would be our 0.4 line. So if we were to multiply this shape by itself, that many times. Now we're not adding two of these shapes together. That's not what multiplication is. Multiplication is not adding two shapes together. What we're doing is we've increased 1 by 41% to get this right here. Now to get to 2, we need to increase this shape by another 41%. And that, if we look at what it would look like doubled, and then we look at what it would look like with 50%, and then we cut it down to that 41%, you will see that it is, in fact, 2. So this one is the square root of 2. This one is 2. This right here, this is 2. And this shaded part is the square root of 2. That's an accurate diagram right there. Okay. So, he then says, how is that multiplication? If it means to make more, increase a number, how is 1 times 1 equaling 1 part of the multiplication table? Okay. So because multiplication is accounting for portions, what Terrence Howard is doing is literally turning multiplication into addition. But apparently only when the numbers 1 and 2 are involved. He has no issue with multiplying large numbers on a calculator. Terrence Howard then says, now I understand if you're seeing it one time, but we call that once. But the moment you add the times in there, so 1 time, but the moment you add the times in there, so the letter S is the issue. Terrence Howard says that multiplicative indicator, that means there's more than 1. So he's saying that this means there's more than 1. But this is saying there is only 1. He's literally confusing multiplication with addition. So multiplication doesn't mean there's more than 1 unless it's being multiplied by a number that is greater than 1. 1 times 1 is 1. 1 times 0.5, let's get into this again. So here's 1, and we are going to account for half of that. Equals 0.5. 1 times 1.5 equals 0.5. This is 3rd grade math, though, which can be tricky. So he then says, so now each equation is supposed to be balanced. You know, that equal sign. It's supposed to show that there's a balance between these two numbers over here and the balance on this one over here. So any number multiplied by 1 is just that number. Any number divided by itself is equal to 1 because it fits perfectly into itself one time with no excess. It's truly elementary. So if you have 1 times a number, it equals that number, and then if you divide that number by itself, it equals 1, which is, as he said, it has to be balanced. It is in fact balanced. If you have 1 times 100, that equals 100, and if you have 100 divided by 100, that equals 1. And you can see that by going like this. 100 divided by 100 is 1, and 1 times 1 equals 1. It's consistent. We could even do it like this. Here is 1 2 times, which we can see is 2. And if we take 2 and divide it by 2, which is cutting it in half, you see that that is 1. So here's an example of the number 2 with multiplications from 1 to 5. So we have 2 1 time, 2 2 times, 2 3 times, 2 4 times, and 2 5 times. And if we want to take this out of abstract math, we can do that too. Let's do it like this. Here's 2 1 time. Here's 2 2 times. Here's 2 3 times. Here's 2 4 times. And here's 2 5 times. So this right here is 2 1 times, or 2 times 1. This is how we do mathematical notation to signify that right there. And if I erase one of these little dots, now this is the mathematical notation to signify that right there. And the answer is 1, not 2. There's only 1 there. There's one object, 1 time. And if we put 2 back in there, that's 1 object, 2 times, or you could even write it as 2 objects 1 time. It's the same thing. It's 2. And this is 2 objects 2 times, which equals 4. And this is 2 objects 3 times, which equals 6. 2 objects 4 times equals 8, and 2 objects 5 times, which equals 10. Terrence Howard, I am really sorry that your 3rd grade teacher failed to help you understand this. And just to get into the one times, let's go back through it. Just erasing these little extras here. Oh, and also 0, right? There is nothing there 1 time. Doesn't matter how many times something is there. If there's nothing there, it's 0. There is not 1 there, as Terrence Howard claimed, and some other video he said that 1 times 0 was 1. Now 1 plus 0 is 1, which is why I'm saying that he's using multiplication as addition. So if we were to write this as multiplication, of course, there is 1 object 1 time, which equals 1. We could also write it as addition. 1 plus 0, because there's just that one and nothing else, equals 1. If we were to write this one out, it is 1 object 2 times, which equals 2, or we can say it's 1 object plus 1 object, which equals 2. This is 1 object 3 times, which equals 3, or 1 object plus 1 object plus 1 object, which equals 3. This is 1 object 4 times, which equals 4, or 1 object plus 1 object plus 1 object plus 1 object equals 4. You get the idea. I'm being really thorough here because this is really simple, and Terrence Howard, I really hope you watch this video. So we can also graph it. Let's graph it on 2 number lines. So one line is the number that we are going to multiply, and the other line is the number of times that we are going to multiply it. We can also do 3 lines. With 2 lines, we will look at numbers when they're squared, and with 3 lines, we'll look at numbers when they're cubed. So these are the Cartesian coordinates. Terrence Howard does not like Cartesian coordinates. And we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's just draw really thin lines. We don't need to worry about the other sides, because this is negative on the x and positive on the y, and this is negative on both, and this is positive on the x and negative on the y. So we're just going to look at the positive numbers right now. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. If we do 1 times 1, we are squaring it, literally making a square. And there is 1 square there. So 1 times 1 equals 1. If we do 1 times 2, this is the times, and this is the number to be multiplied. Right, so 1 times 2, you can see that it is 2 boxes. If we do 2 times 2, we can see that 2 times 2 is equal to 4. There are 4 boxes. 3 times 3 is equal to 9. There are 9 boxes. 4 times 4 makes 16 boxes. 5 times 5 makes 25 boxes. The square root of 25 is 5. The square root of 16, right, is 25. This one's 16. Let's do a different color. This one's 25. This one's 16. This one's 9. This one's 4. This one's 1. The square root of 25 is 5. The square root of 16 is 4. The square root of 9 is 3. The square root of 4 is 2. The square root of 1 is 1. And we write the square root of 2, for example, because that's a difficult number to square root, because it's not in this nice easy progression. We write it with just the square root on it, or we write it out as the decimal notation. And if you do that math, it equals 2. There's nothing wrong there. It's not messed up. And if this equals 2, and 1.4 plus 1.4 equals 2.8, and 2 times 1.4 is the exact same thing as 1.4 plus 1.4, right? Because 2 times 1 is the exact same thing as 1 plus 1. Then you get the same exact answer. Pretty wild. Okay. Let's do it with cubes, because we're going to be real thorough here. So, Cartesian coordinates again, but this time 3 dimensions. This is the x, this is the y, this is the z. Actually, let's do it the way they normally do it. This is the y now. We've flipped it onto its side. Z is now going to be up and down. And then we're going to do 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now, if we have 1 times 1 times 1, we create literally a little cube, and we create 1 cube. Let's get real accurate on this. So this goes to there, that goes to there. There, we have 1 cube. So 1 times 1 is still just one thing. It's just one little cube. 1 times 1 times 1. Now, if we were to go with Terrence Howard's version of this, 1 times 1 equals 2. So this is equal to 2. And this one, 2 times 1, I don't know, would that equal 3 to him? Would that still equal 2? You'd have to ask him, because he's not really consistent, so it would be hard to guess what's going on there. But no matter how many times you multiply something by 1, it's just one instance of that thing. Even if you start increasing the dimensions of it. Now, in a way, if you could say, in a weird way, that 1 times 1 equals 4, in the sense that you went from one of these things to 4 of them. And that would actually make more sense than what Terrence Howard is saying. Because now you're talking about 4 objects in 2-dimensional, 4 lines in 2-dimensional space. And then when you're talking about 3-dimensional space, you could say that 1 times 1 times 1 is made of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Imagine that. Imagine 1 times 1 times 1 equals 12. But you know what's cool about this is it's fucking consistent. You can actually do real math with this. You're using math in unconventional ways, but it's actually consistent as long as you stick with the same conventions. Which means that if you throw a 2 in here, we can calculate that. Now it's 1, 2, 3, 4, 5, 6, 7, 8 more. So you can say that 1 times 1 times 2 equals 20. It's not the way that we use multiplication, but it has an actual basis in reality. It's just a different way of notating it. But anyway, we're not going to do that. But, you know, if Terrence Howard, if you want ideas, I'll give you ideas, man. Hook me up. I need a job. My job sucks. Okay. So this right here is now 2 times 1 times 1. And what we get is 1 times 1 equals 1 times 2 equals 2. We have 2 cubes, because that's what we're counting. We're counting the number of objects in the space provided. If we throw in another 2 over here, so it's 2 times 2 times 1, now we have 4 cubes. So it's 2 of those, 2 times 2 times 2 times 1 is the same thing as 4 times 1, or 2 times 2. They all equal 4. If we then make the next one 2, we now go into the other one. And if we go with our funky how many lines math, let's see here. What did we have? We had 4 and 4, and 4 was 12, plus, was that 8 more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I think that's 24. We'll just say that's 24. So we could do some quick math here. 24 plus another 24 minus the where they intersect. There's 4, 5, 6, 7, 8, 9, 10, 11, 12. Minus 12, so 36. Right? That should be right. We could say in funky one-dimensional math instead of 3-dimensional math. In one-dimensional math, 2 times 2 times 2 equals 36. But in 3-dimensional math, 2 times 2 times 2 equals 8. And you can count the cubes. I know this is really scribbly all of a sudden, but we've got 1 cube here, 1 cube here, 1 cube here, 1 cube here. That's 4. Plus 4 more on the bottom. That's 8 cubes. So there you go. Elementary math in 3 dimensions. plus some funky one-dimensional math in 3D, creating bigger numbers, which honestly could be explored and could be fun. Maybe I'll do it someday. Okay. Where are we at? Okay, Terrence Howard says, what happened to the other one in this equation, right? So he sees two ones, and therefore he wants to add them together to make 2. He says, it does not, it didn't equate. And then I took the square root of that number, 2, because all of this started in the 3rd grade. I was arguing with my teacher. We were talking about the square root of 100. Let's go over the square root of 100. So, square root of 100, written like this. The answer is 10, because 10 times 10 equals 100. And when you multiply things by 10, it's really easy. You could just take that 0 and tack it onto the end there. So 5 times 10, easy, 50. No big deal. 10 is really fun to play with like that. Let's draw it out in a diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects. And we want 100 objects. So let's make 10. This is going to be our row. We're going to make columns. We're going to make 10 columns. Well, they're already in columns, but we're going to put 10 in every column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's just do it for all of them. This is what Terrence Howard was arguing with his teacher about. The square root of 100. We're going to do all of them. We're going to literally draw 100 circles. Not all of these are perfect circles. I just don't feel like doing that. Freehand is more fun. And faster. Well, I'll have to put my stylus down. I could theoretically do this faster if I just copied and pasted. Anyway. So what we have here is a number of objects, which there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects. And we have a number of rows of these objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 objects 10 times, or 10 times 10. Let's count them by tens, okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 100 is 10 times 10, which means that the square root is one of those, which is 10. Terrence Howard, I'm sorry that your 3rd grade teacher failed you so badly. Okay. Let's see, what else did he say? Oh yeah. Let's just say, how many times do you see the number 1 there? You see it 1 time. That's 1 times 1. How many times do you see the number 1 inside of this box here? There's one 1 inside of that box. 1 times 1. How many 1s are inside of this box? There aren't any. That's 0 times 1. There are 0 1s in that box, so the answer is 0. It's not there. That's 0 times 1. So Terrence Howard thinks that he's looking at 0 times 1. has to equal 1 because there is a 1 there. But 0 times 1 is how many zeros got put inside of this box. Or how many 1s are there inside of this box? There are none. We can see inside of the box, we've got X-ray vision. There is not a single 1 in there. If we were to put a 1 in there, it's no longer 0 times 1, it's now 1 times 1. There is 1 1 in that box, 1 time. Okay, so the interesting thing is that he's literally treating the time symbol as a plus symbol, essentially, but only for small problems. If you asked Terrence Howard, what is 5,280 times 12, he gets the right answer. The answer, let's find out. 5280, 12 times. It's the same thing that we were doing with all the other stuff. Let's do it in rows. Like this. And the smart children amongst us might notice that this is a row of 4 and this is a row of 3, which means that we have 12 total of these 5,280s. And if we add them all up, that's 10,000 plus 10,000 plus 10,000 plus 10,000 plus another 10,000 plus another 10,000, and that's also 400 plus 400, we'll call that 800, and another 800, and another 800. And then we also have all these 80s. So that's 320 over there, and that's 320 over there, and 320 over there, because 8 plus 8 equals 16, and 16 plus 16 equals 32. And it's 80s, so you add a 0 on there. So if we add these all up, 8 and 3s become 11s. Oh, let's yeah. So we now have 1,120 here, 1,120 here, and 1,120 over here. If we add those up, we have 3,360. And then we add up all these, which is 6 times 10,000, and that is 63,360. Now check this wizardry out. I'm good. Right, let's just erase some of those. We're going to now do the same thing with the number 5. Just the number 5. Exact same setup. 5 plus 5 is 10. 5 plus 5 is 10. There's 20 of those. There's 20 there, and 20 there. The answer is 60. What if we cut that in half? Now, we've just divided it by 2, by the way. Right? Because we've got 1/2 over here and 1/2 over there, and we're only counting for 1/2 of it. We now have 10, and 10, and 10 is 30. And what if we turn all these 5s into 1s? What we have here is we have 2 times 3, or 1, 2, 3, 4, 5, 6 1s. 2 times 3 is 6. 1 plus 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5, 6. 6 1s. Crazy. What if we get rid of all that crap? We have 2 1s left. That is 2 times 1. 1 times 2 equals 2. 1 plus 1 equals 2. 1 plus 1. Now, what if we get rid of the last one? We have only 1 left. What do we have? We have 1 and 1. 1 times 1 equals 1. There's only one thing left. So the same exact principles that get 5,280 times 12 equals 63,360, which Terrence Howard knows how to do. He puts it into a calculator, gets that answer, gives you 1 times 1 equals 1. Jesus Christ, Terrence Howard. What did you do to my brain? Okay. Yeah. 1 times 1 equals 1. Okay. God, if he uses that, I'm going to cry. I'm going to redo this whole video. Okay. And there's the problem with profitability, says Terrence Howard. Profitability, no. He said, and there's the problem with probability. The Heisenberg uncertainty, Schrödinger, all of those were just probabilities because they had taken the ether out. They forgot that the electromagnetic wave, it had to have a medium on which it followed on. It had to have something in which it was moving on. Now, I mean, this is not a bad assertion, right? If you have a wave in water, it's waving in the water. So if you have an electromagnetic field waving, what's it waving on? Well, it's waving on the electromagnetic field line, which comes out of the proton and goes into electrons. Right? So, and what's cool is that all these field lines connect all over the place. Right? So, if you have a wave in this electromagnetic field line, this is, an energy in the field, the electron gets excited. And then the electron, which even though it's flowing inward, it's still an ever-present field around it. And when it waves that field, it is going from a different excitation state to create that wave. And that wave keeps going until it hits another electron, and then that electron gets excited. And then that electron sends it on, and so on. And that's how you have the electromagnetic wave of light hitting an electron, getting absorbed, the electron gets excited, then it stops being excited, sends that wave back on, and so on. So what Terrence Howard is basically saying is that there needs to be a medium for this wave to pass through. But what we have seen is that there's these lines, literal lines of energy that come out of things like magnets. And those lines are what get vibrated, and it's both electricity and magnetism at the same time. It's the electromagnetic field, and we can see it. If you take a plate of glass, it doesn't have to be circular, but it's fun if it's circular. Take a plate of glass and another plate of glass, and you put ferrofluid mixed with like vegetable oil. You get one little drop of ferrofluid, you get a little bit of oil, and you spread it into this glass, right? And then you tape LEDs all along the outside, all shining in on this very thin layer of oil and ferrofluid. And the ferrofluid is important because ferro means iron, which means it's a magnetic fluid, right? And then you take a magnet and you put the magnet up against what we call a ferrocell, right? I don't know why we call it a cell. Maybe it's because it's circular. But anyway, you put it up next to this ferrofluid in between these two plates of glass. What you're going to see is the electromagnetic field lines that are literally the lines that light travels on. It's awesome. In fact, I'm going to pull one up for you. That's how cool it is. 1 second.
Out.
Check that out. That's a magnet, and it's showing you the electromagnetic field. You can literally see it with your own eyeballs. You can see exactly what it's doing. These things are amazing. And what's really cool is it's like, even though you're looking on a two-dimensional plane, because it's a three-dimensional field, you're seeing like a weaker effect towards the edges because the field is actually in 3 dimensions. And then here's like a little explanation of how it works. You can make one of these things yourself. It's not hard. 2 plates of glass, some oil, some ferrofluid, you can buy the stuff online, some LED lights around the side, some tape, some glue maybe, and you've got yourself a way to see actual electromagnetic fields in action. It's awesome. All right, continuing on. So, Terrence Howard says the problem with the Heisenberg uncertainty principle, Schrodinger, he's talking about quantum mechanics basically, is that they left the ether out, that they forgot the electromagnetic wave had to wave on something. So the logic here does not follow. All of those were just probabilities because, and does not connect to they had taken the ether out. Or that does not connect to they had taken the ether out. That is not why quantum mechanics deals in probabilities. It deals in probabilities because all of the data required for definite measurement. Hold on, I'm gonna go back to my drawing board here. So all of the data required for definite measurement cannot be obtained. They can't measure an electron without disturbing the electron. So in order to measure this electron, they have to bounce something off of it, like a light wave, which I think that's the symbol for a light wave. And let's go with Feynman diagrams. This is going to be a really bad Feynman diagram. But so you have a light wave, right? You're bouncing a light wave off of an electron so that you can detect the angle at which you know the angle at which you sent the light wave out. You detect the angle at which the light wave came back, and actually it's probably going to keep going in the same direction, so this might be a terrible example. But the electron is going to absorb that photon, basically, or the light wave, and then send it back out, and you're going to detect it somewhere, and you'll be able to tell where the photon was in the electron, or in the area, or how fast it is moving based on hitting, like multiple times or something. Or I don't know. It's you can look this stuff up. It's a little bit complex, but the basic idea is you can't measure an electron without doing something to the electron. If the electron was moving this way, and you hit it with a photon moving this way, you're gonna affect the electron's trajectory in some way. And that's why when you have a double slit experiment and you've got electrons coming through here, making their waves, creating interference patterns with each other, right? And hitting the detector fields at certain points based on where those waves connect. If you hit it with light first to observe the electron moving through these gates, the electrons are now more affected by the photon than they were by their own little bounces, creating little wave ripples in the electromagnetic field, right? And now they're just going to hit straight on, because you had to interact with them by hitting them with light. In order to observe an electron, you have to bump into it with something, and it's so small that even just one little pulse of light is going to change its course. And this has to do with the Heisenberg uncertainty principle of you can either measure a position or a velocity, but not both at the same time, because it's just too small. Let's see here. So this is actually a lot like if you were to take macro objects, bowling pins, right? You've got some bowling pins set up. I'm not going to draw all 10, but we'll draw 6 bowling pins, ish. 6 bowling pins, and you're going to hit it with a bowling ball. Right? If you know where those bowling pins are, you know what they're going to do. You can see the bowling pins. You know what the bowling pins are going to do based on all the physics. Now, if you're just a guy bowling, obviously you're not making accurate measurements to know exactly what the bowling ball is going to do to those bowling pins. But if you're a crazy physicist and you want to really figure it out, you can. You can control all the variables, and you'll find out exactly where the bowling ball impacts affects where it goes. And as a bowler, you have a vague idea. You know that at the first pin you want to hit it about here, and that'll take out all the pins. But now let's say you've got a wall back here that is your detector, and you have a little plate that can move back and forth with one bowling pin on it. And it's pitch black. You can't see any of this. And you throw your bowling ball down here. You have no way of knowing if you hit the bowling pin until it bounces off of the bowling ball and smacks into your detector screen in the back. That's how they do particle physics, because that stuff is so small they can't see what's going on. They can see it when it hits into their detectors, but they can't see the impact itself. So the only way to measure whether or not you are going to hit this pin is by using probabilistic measurements. You're using statistics. You throw your bowling ball, you throw your bowling ball, you throw your bowling ball, you throw your bowling ball. You just keep throwing it, and sometimes you hit. And sometimes you don't. And sometimes, you hit it in this direction. Sometimes you hit it this direction. Sometimes you hit it in this direction. And you have to figure out, based on that collision, either where that pin was when it got hit or how fast it was moving. Because we also don't know how fast it's moving. If we throw like a whole ton of bowling balls, we get to know basically where it is by throwing all these bowling balls at once. It hits here, ends up here. We're like, okay, the pin had to be like here maybe, unless it was like way over here. But that'll show up a little bit differently. Anyway, we're getting real scribbly here. But it's basically like macro level physics without any of the information, because it's just too small. And there may be some quantum physicists out there who disagree that quantum physics can be expressed in the macro, but people also say that a casino die that is perfectly balanced is random, right? You think of that as perfectly random, and the only way to measure it is with probability. But that's not true. If you can calculate with extreme precision all of the variables of that die bouncing off the table, and how it was thrown, and how it's rotating when it was thrown, and what's its exact weight, and what's this table made out of, and what's this die made of, and how do these things interact when they collide at this exact angle, at this exact speed. You do all that, you will know exactly what that die is going to land on at any given point. It is possible to measure it if you are able to accurately measure all of the variables. Quantum mechanics, it's too small to measure those variables, and an electron is like, it's not a bowling ball, it's not a pool ball, it's like a vibrational thing that has like a certain number of nodes at certain states of excitation. We literally cannot see what it actually looks like. So that's a pretty good example of what an electron might be. Or like if it's got 3 nodes in it, it's gonna be like that with a circle, and it's like going up and down, and then up, and then down, and then up, and then down, and so on and so forth. And it's creating these excitation states that we call the electron shells, right? Because like maybe for example you can fit 3 in this shell, right? That's terrible, but you can fit 3 vibration nodes on that shell, and then you can fit way more vibration nodes on this shell, and then way more on this shell. That's basically an electron. And if you wanted to measure the electron, like, good luck, you can't see it. That's why we have quantum mechanics. Anyway, rant over. Let's go to the next Terrence Howard quote. How long has this been going? 3 hours and 46 minutes. We've now hit how long it took for Joe Rogan to interview Terrence Howard. Geez, I don't know how much I have left, but it might be like double. So kudos to anyone actually watching this. Terrence Howard says, "It cannot be the cause of its own action. An effect can never be the cause of the action. The egg cannot come before the chicken. The chicken has to be there first. Before, in order to lay it, it has to mate. And what Einstein left out was the equal and opposite of magnetism." This is a non sequitur, which is a fancier way of saying it does not follow. Probabilities don't have anything to do with effects being self-caused. Also, an aside, the egg does come before the chicken. A precursor to a chicken had to lay a chicken egg at some point in its evolution before the chicken could come out. I can't draw a chicken. Here's a chicken. Okay, so whatever laid this egg that became a chicken was not a chicken. This egg was a mutation which led to the very first chicken, which means that the very first egg that the very first chicken came out of was a chicken egg. It was laid by not a chicken, but it was almost a chicken. And at some point it was a T-Rex. A precursor to a chicken has to lay an egg which is genetically mutated and results in a chicken before a chicken can lay an egg. Until we regress so far back that the precursor to the egg-laying creature isn't laying eggs to reproduce. And then we're dealing with genetic mutations from other forms of reproduction. You'll have to explain to Maxwell about the fact that Einstein supposedly left out the equal and opposite of magnetism because it was Maxwell that dealt with electromagnetism. And he definitely did not leave the electro out of electromagnetism. Terrence Howard says, and I'm like, dude, I've done it. I've got it right here. But based on everything that we've gone over, Terrence Howard really doesn't have anything. It would be really cool if Terrence Howard did have something special here. That'd be all about it. Like the beryllium in the water thing. If that was real, that'd be amazing. But it's not. Terrence Howard says, his work looks a lot like my stuff, but he put those straight lines in there. Giordano Bruno. I think he put those straight lines in there to appease the church so they wouldn't kill him. And they still killed him, because he wouldn't recant that the God they were talking about wasn't the true God of the universe. It was much larger than that. So curved lines are an affront to the church. Well, that's the first I've heard of it. It's funny how they have all of those curved domes in their buildings with the mandalas in them, which represent something real, which is beyond the beyond the normal scope of physical understanding. It's an hourglass-shaped toroidal field. That you're looking up into. And there's a singularity right there at the center of a torus. That's what those domes are all about, by the way. And that's not me just talking out of my ass. I'll do a whole video on that one. Those mandalas, that specific dome shape, that stuff is real. And these domes are a reference to it. And that is a curved object. So the church didn't kill Giordano Bruno because he left curves out of his straight lines, right? He was probably talking about platonic solids, like cubes, tetrahedrons, octahedrons. That was a terrible drawing of an octahedron. Anyway, they killed Giordano Bruno because he said their God was fake and that there was a bigger God. And they don't like that stuff, those Christians, or Catholics, or whoever they were. So, Terrence Howard then says, all of the planets in every solar system is drifting away from their primary at the exact same rate. I drew Jupiter way too big. But then again, I drew everything too big. Anyway. So Terrence Howard continues, like 1.5 centimeters. I think he means per year. And then he says, so this is a universal expansion that is happening with everything moving away. If you just add up linearly how long it would take the Earth to go from the sun to 93 million miles away, it's 9 trillion. So this is the math. 5280 feet in a mile, 12 inches in a foot. Therefore, 1 mile equals 63,360 inches. Remember that? 5280 times 12? He can do big math. Inches. So the number of years it would take for the Earth to move 1 mile is 105,600 years. So in order for the Earth to reach where we are at 93 million miles, to get here, Likewise, Mars, at 147 million miles away from the Sun, would take, what was that, 1,000 million billion? It would take 15 trillion 780 billion 480 million years for Mars to get where it was. So at a given point, Mars was here in the Goldilocks zone, and now Venus will be in the Goldilocks zone next. The Sun will get, Mercury is under higher pressure because they're still under the mistake thinking that there's a void in space. So they forget that Mercury is under the highest pressure possible, so it can't expand. It's like hydrogen, it's like those octaves before hydrogen. So the atmosphere, the iron, isn't able to release any oxygen in the oxides. But when you get to 67 million miles away from the Sun, the pressure is a little less, but it's much higher than the pressure on Earth. It's like going deep into the belly of the Earth. That pressure is so very high. And so now the clouds, there's a great deal of sulfur, ammonia, and all of those things in it. But once Earth moves to where Mars is, Venus is going to slowly move, and it will be right here. You will know in maybe 5 or 6 trillion years, in maybe 5 or 6 trillion years, and humanoids will appear again and unwind the same way. So all of that is based on Walter Russell's ideas of the Sun creating a pressure field around it, and as you spiral out from the Sun, your elements go from hydrogen to carbon and all those other things. Like hydrogen literally comes from the Sun and becomes carbon as it gets farther away. That's the claim. And so he's saying, I'll just read what I wrote. So the orbital distance of the planets increases due to the Sun losing mass by radiating energy and by tidal forces. Not all of the planets are on the same ecliptic. I think I have something for that. Is that this one? This one? This one? This one? No. I might not have one of those. I got a lot of stuff, but I don't have the ecliptics of the solar system. But like Pluto, for example, Pluto is way off. Let's go back to this thing. This is what he's basing this idea off of. Okay. So not all of the planets are on the same ecliptic. The entirety of this claim is based on Walter Russell's ideas of pressure. The idea that Mercury is small because it is close to the Sun, and that it will eventually be where Earth is today and expand to be larger as the pressure is lessened, is the same basis for the idea that the elements unravel into larger elements like hydrogen becoming carbon. This does not line up with the chemical composition of Mercury or Venus or Earth or Mars or any other planet. Definitely doesn't make sense for Saturn being smaller than Jupiter, or Uranus and Neptune being smaller than both, or Pluto or Eris or Maki Maki. It is a fantasy cosmology, and the principles it is built on are not well thought out. It's not universally applied to the entire system, and it does not make consistently accurate predictions, such as beryllium interacting with water. Terrence Howard next talks about how he believes the asteroid belt was a planet that has been labeled Ceres, and that it had humanoids on it, and was positioned where Earth exists currently, and it was hollow inside, and the humanoids popped it with a hadron collider. I'm not going to address beliefs. This video is for addressing claims, but he did say those things.